Is the era of large language models already over? Can AI truly learn to reason? And if so, how close are we to unlocking a technological singularity? And most importantly, what do these breakthroughs mean for developers, businesses, and humanity as a whole? My name is Cyril Sadowski, I work for Deutsche Telekom, and I will try to answer these questions from my personal experience as lead AI engineer. But before we start, let's have a look at this short clip from OpenAI's introductory video to the latest Frontier O3 model.
Somehow very cool to just ask a model to evaluate itself like this.
Exactly, right? And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this hard GPQA data set from a UI, right? From this code generator and executor created by the model itself in the first place.
Next year, we're going to bring you on and you're going to have to ask the model to improve itself.
Yeah, let's definitely ask the model to improve it next time.
Maybe not.
Engineers are joking that if a model is able to evaluate itself, maybe they should let it improve itself. When Sam Altman jumps in and stops the debate a bit abruptly. And then, for a few seconds, there was an awkward silence. With the original LLM ChatGPT 3.5 released in October of 2022, we as engineers came to quick realization that the LLM is great, however, it is not reliable enough to be included in any kind of practical workflow. Then GPT-4 was a lot better. It helps a lot with tasks where you need to brainstorm more when compared to coming up with foolproof solutions. However, it still wasn't good enough. We even published a white paper, The Human-AI Synergy, Redefining the Role of Generative AI in Strategic Planning and Decision Making, which you can see on your screen right now, where we explore the shortcomings of LLMs. Well, the experiment we conducted was a pretty simple one. We let two GPT-4 players play against each other a very simple board game. You can read about it in more detail in the white paper, but the short version is this. GPT-4 was just not even able to make enough valid moves before it ran out of budget. And we can clearly see it in this table. So as you can see, on the left, there is a column move count, and when we compare it to total LLM calls to make one valid move, on the opposite side on the right in the column efficiency, you can see that it wasn't very efficient. It took several calls to the LLM to be able to make one valid move. And in the point 5, we remark the experiment incurred a substantial computational costs, approximately 50 to 100 euros per hour, while producing no tangible strategic gains, highlighting the potential economic inefficiencies in deploying LLMs for complex decision making. A lot of research has been done on this subject, where researchers are exploring planning capabilities of LLMs. Planning capabilities are important because if an agent has good enough planning capabilities, the higher reliability in an agentic chain it has. One of those studies is LLMs can't plan, but can help planning in LLM modular frameworks. And this table shows LLM capabilities to plan, or quote-unquote to think in steps. Essentially, block world is a type of game or a task where a human or an AI have to find the correct way of stacking blocks on top of each other. As you can see, the LLMs are not very successful, as the best score is only 34.6%. There are algorithms that can solve these type of tasks in fractions of seconds with almost no associated costs, and more importantly, with 100% reliability. That's all true for large language models, but OpenAI have recently released a new type of models, large reasoning models. In October, it was a large reasoning model O1, and in December 2024, it is already O3 model. If we have a look at simple benchmarks, already we see how much of a leap this is. However, O3 broke even one other benchmark, which is called ARC price. Greg Kamerad will explain what this benchmark is on OpenAI's live stream.
In addition to Epic AI's Frontier Math benchmark, we have one more surprise for you guys. So I want to talk about the ARC benchmark at this point, but I would love to invite one of our friends, Greg, who is the president of the ARC Foundation, on to talk about this benchmark.
Wonderful. Sam and Mark, thank you very much for having us today.
Of course.
Hello, everybody. My name is Greg Kamerad, and I'm the president of the ARC Prize Foundation. Now, ARC Prize is a nonprofit with the mission of being a North Star towards AGI through and during benchmarks. So our first benchmark, ARC AGI, was developed in 2019 by Francois Chollet in his paper on the measure of intelligence. However, it has been unbeaten for 5 years. Now, in AI world, it feels like centuries is where it is. So the system that beats ARC AGI is going to be an important milestone towards general intelligence. But I'm excited to say today that we have a new state-of-the-art score to announce. Before I get into that though, I want to talk about what ARC AGI is. So I would love to show you an example here. ARC AGI is all about having input examples and output examples.
Well, they're good.
They're good? Okay. Input examples and output examples. Now the goal is you want to understand the rule of the transformation and guess it on the output. So, Sam, what do you think is happening in here?
Probably putting a dark blue square in the empty space.
See, yes, that is exactly it. Now, that is really, it's easy for humans to intuitively guess what that is. It's actually surprisingly hard for AI to understand what's going on. So I want to show one more hard example here. Now, Mark, I'm going to put you on the spot. What do you think is going on in this task?
Okay, so you take each of these yellow squares, you count the number of colored kind of squares there, and you create a border of that width.
That is exactly it, and that's much quicker than most people, so congratulations on that. What's interesting though is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ARC AGI is every task requires distinct skills. And what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ARC AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC AGI Pub. So congratulations to that.
Thank you so much, yeah.
Now, as a capabilities demonstration, when we ask O3 to think longer and we actually ramp up to high compute, O3 was able to score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand. So this is new territory in the ARC AGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah.
Did you see how Sam Altman immediately corrected Greg when Greg made a mistake in the numbers to emphasize how powerful the O3 model is? Well, as you can see, the ARC benchmark was a very tough nut to crack, but the O3 model, at least it seems, from what we know, is performing already on levels not achieved by a majority of people. This has a lot of implications actually. It seems, again at least to me, that OpenAI and perhaps other AI labs are making big progress in understanding how reasoning works and how to apply it to their AI models. In a recent interview with Sam Altman, he speaks about how companies, founders, and startups should think about applying AI capabilities. By the way, when the interview was released, the O3 model wasn't yet introduced to the public, so I think Sam Altman is already trying to hint at how the market should behave because he has insiders' information. Well, of course he has.
One that I thought was really important for us to touch on was when we look forward to OpenAI's future plans, how do you think about developing no-code tools for non-technical founders to build and scale AI apps? How do you think about that?
It'll get there for sure. I think the first step will be tools that make people who know how to code well more productive. But eventually, I think we can offer really high-quality no-code tools, and already there's some out there that make sense. But you can't sort of in a no-code way say I have like a full startup I want to build. That's going to take a while.
So when we look at where we are in the stack today, OpenAI sits in a certain place. How far up the stack is OpenAI going to go? I think it's a brilliant question, but if you're spending a lot of time tuning your RAG system, is this a waste of time because OpenAI ultimately thinks they'll own this part of the application layer, or is it not? And how do you answer a founder who has that question?
The general answer we try to give is, and you have to assume that we're biased here and talking our book and may be wrong, but the general answer we try to give is we are going to try our hardest and believe we will succeed at making our models better and better and better. And if you are building a business that patches some current small shortcomings, if we do our job right, then that will not be as important in the future. If, on the other hand, you build a company that benefits from the model getting better and better, if an Oracle told you today that O4 was going to be just absolutely incredible and do all of these things that right now feel impossible, and you were happy about that, then maybe we're wrong, but at least that's what we're going for. And if instead you say, okay, there's this area where there are many, but you pick one of the many areas where O1 preview underperforms, and so I'm going to patch this and just barely get it to work, then you're sort of assuming that the next turn of the model crank won't be as good as we think it will be. And that is the general philosophical message we try to get out to startups. Like, we believe that we are on a quite steep trajectory of improvement, and that the current shortcomings of the models today will just be taken care of by future generations. And, I would encourage people to be aligned with that.
So we did an interview before with Brad, and sorry, it's not quite on schedule, but I think the show's always been successful when we kind of go a little bit off schedule. There was this brilliant, sorry for that, but there was this brilliant kind of meme that came out of it, and I felt a little bit guilty, but you said wearing this 20 VC jump, which is an incredibly proud moment for me, for certain segments like the one you mentioned there would be the potential to steamroll. If you're thinking as a founder today building, where is OpenAI going to potentially come and steamroll versus where they're not? Also for me as an investor, trying to invest in opportunities that aren't going to get damaged. How should founders and me as an investor think about that?
There will be many trillions of dollars of market cap that gets created, new market cap that gets created by using AI to build products and services that were either impossible or quite impractical before. To build something to go deliver like the great AI tutor or the great AI medical advisor or whatever. And so I felt like 95% of people that were like betting against the models getting better, 5% of people were betting for the models getting better. I think that's now reversed. I think people have like internalized the rate of improvement and have heard us on what we intend to do.
It is left to our imagination what all three and maybe O4 models powered by nuclear reactors can be used for, but I have a very particular use case from my own profession where I think it is getting apparent how problematic keeping up with the tech can be. Noah Brown from OpenAI even thinks that the progress will accelerate.
Do you think model progress in 2025 will be more or less or the same as 24?
I think that we will see progress accelerate.
The particular use case I am talking about is structured output. One of the scaffolding many developers, including me, are trying to build around foundational models is the capability to output structured data. Something like, JSON, XML, YAML, or anything of such sort. OpenAI engineers did a great job at explaining the problem.
Here's an example. Let's say you're building a personal assistant, and you want to convert the user's message into an API call. The user might say, play the Beatles. Here's what you expect. You want a JSON object that says, play music for the API and the Beatles for the artist. But too often, here's what you get. The model begins with a preamble, saying, sure, here's the JSON to call the Play Music API. Now, this isn't particularly helpful for developers, since we need just the JSON, not the text surrounding it. This is a problem. LLM outputs are not always reliable, making it hard to integrate them into your apps. Now, as developers, we've tried all kinds of tricks to solve this. Some of you may have written prompts like this, or even this. Now, sometimes it works, and sometimes you have to go all the way and write a custom markdown parser. That's obviously not how it should work. So, to solve this problem, in June last year, we launched function calling.
In our advanced coding assistant, which we open sourced recently, I was also trying to work with this uncertainty around model outputs when the output string has to be restricted. In this very simple example, I just want a yes or no from the model if the database should or should not be accessed. However, I can never be sure about the output, so I had to program very defensively, as you can see on the line 348. First of all, I convert the string to lowercase, and then I am only checking whether the response from the model contains at least a no. Because the answer could actually be, no, we do not require access to the database. Okay, but what if the answer is probably or I'm unsure? There is actually no way how to figure out how to approach these uncertain responses. But now OpenAI claims the models are able to follow JSON schema 100%. That sounds very promising, although I haven't tested it yet. The most important point I want to touch is this. In January 2025, I am starting to work on a new project at Deutsche Telekom associated with AI. Of course, I cannot share the details, but I can at least share what the general purpose of the project is and how it ties in with the structured output guarantees by OpenAI.
Okay, so that showed us the feature, but let's get into some more interesting demos and how you might use structured outputs in your applications. Let's imagine we're building a fictitious company called Convex. Convex is an AI-powered recruiting tool. It lets recruiters create job postings, submit referrals, and schedule interviews. Behind the scenes, Convex is a Node and React app that uses response formats to extract information from resumes and uses function calling to perform queries over the candidate data. Let's see it in action. So I've gone ahead and created a job posting here for an ML engineer role that we're hiring at OpenAI. And you can see the job description, the hiring manager, and some of the candidates that have already applied. Now, before I came on stage, a promising candidate reached out to me and shared his resume. Let's take a look. Okay, Greg seems to have worked at Stripe and has a little bit of experience working in AI. He has a whole bunch of skills, including coding and Python, so seems like a promising candidate. Let's put in a referral. So I'm going to go click in the Add Candidate button here and select Greg's resume. And you can see that we're outputting the fields from the resume in real time. The model is using structured outputs to extract this information from the text that's within the PDF. let's take a look at the model's response behind the scenes. So we see a JSON object with name, title, location, contact info, work experience. All of this has been extracted from the resume. Now, let's take a look at the code to see how this all works. So behind the scenes, we're using a response format called resume. It has the fields we just saw, like name, title, location, and so on. And in particular, for work experience, you'll notice that I'm using an array. So structured output supports a wide subset of JSON schema, including arrays. That allows the model to output more than one work experience. Now, some of the JavaScript developers in the room might also notice that I'm using the library Zod to define my schema. Zod is great. It lets me define my schemas in code and get runtime type safety. The OpenAI Node SDK has native support for Zod. You can define your schemas in it, and when the model starts responding, we parse the response back into the Zod object as well, and it supports streaming. Very similarly, the OpenAI Python SDK supports Pydantic natively.
The new project at Deutsche Telekom should be exactly about extracting unstructured data from PDF or similar formats into object models. Therefore, I introduced a rather substantial experiment with OpenAI Vision capabilities to test out whether extracting structured data would work. When ChatGPT and other LLMs were generally introduced to the public, one of the first capabilities I noticed, except of course text summarization, was the capability to extract structured data. At first from text, and then afterwards from images, for example. However, the LLMs were not reliable enough. I hope I showed you with the GPT-4o's capabilities to guarantee JSON schema, and plus its ability to extract such data from text, makes OpenAI LLMs much more reliable and usable. Well, I say finally. Of course, I haven't tested these capabilities yet, but I think that OpenAI made my job and my new project actually a lot easier. Okay, so this brings me to two main points of this video. First one. Structured output and advanced reasoning enables efficient knowledge extraction from world models. This actually is Neuro-Symbolic AI. Second point, me not being able to keep up with the technology. Okay, so let's try to tackle these 2 points. So first one, Neuro-Symbolic AI is a powerful concept which enables extraction of actionable knowledge from the extensive world model, which is encased by the foundational models like GPT-4. If you remember AlphaGo or even AlphaFold from Google DeepMind, these are Neuro-Symbolic products. I have a presentation on Neuro-Symbolic AI, and I will leave it in the link in the description, but I recommend that you watch it. But with the structured output and reasoning advancements, even more people will gain access to these very powerful and very potent tools. And the second point, regarding me not being able to keep up with the technology, I feel like this is the definition of technological singularity. Technological singularity is a hypothetical future point in time at which technological growth becomes uncontrollable and irreversible, resulting in unforeseen consequences for human civilization. And you have to understand, I am by no means a technological genius, but generally speaking, I was always able to keep up with the tech development. I have also been speaking lately to fellow AI researchers and engineers, and many of them are actually expressing the same sentiment. It's harder and harder to keep up. Just as something new comes out and I come to understand it a bit more deeply, suddenly there are more advancements which completely or at least partially alter my workflows and thoughts on the tech. So when I was devising an experiment for the new project at Deutsche Telekom, I was thinking about how to push the foundational models to deliver what I need. And of course this means like fine-tuning, prompt engineering, thinking about and actually thinking about failure thresholds that would be acceptable for the customer. Suddenly, there is a complete shift in the AI tech, and I don't have to worry anymore about that. The same thing happened with our white paper, The Human AI Synergy, where we cautioned execs and engineers about large language model reasoning capabilities. We published the white paper just in August 2024, but already 1 month later, in September 2024, there was a new paradigm of foundational models, the Large Reasoning Model 01, and then already in December 2024, so again 3 months later, 03 got announced, which is completely crushing reasoning benchmarks. And then, as Noam Brown claims, 2025 will be even faster. So even if we still don't classify this as technological singularity, I can definitely feel the pressure building up. So then a natural question comes to mind. What now? Well, I personally think we are living in the most interesting times in history. Many shifts will probably happen in the next decade. Maybe the humanity will be destroyed, or maybe we will find the Holy Grail and live forever thanks to the new healthcare breakthroughs. Or maybe some combination of that. No matter what happens, I think we should at least try to enjoy the ride and make the best of it. If you like this video, please leave a like. If you are interested in the kind of work that I do, please subscribe. I am starting a new fundamental research on an ultimate reward function, and I will be publishing the results iteratively on my Substack, so with subscription you get notified. Have a great day.